Hey everyone, so I wanted to make a quick video explaining these transformations from our study guide. So I know the questions are a little bit here on the left hand side, so just follow along with my study guide because I couldn't get it all in one shot. So first thing it's asking us is to rotate quadrilateral NOPQ about point M 90 degrees. So I'm going to rotate this quadrilateral around this point M, knowing that this is the center of the rotation is very important. So what I recommend is taking a separate piece of paper and tracing, which I already did. I traced this figure. I'm going to overlay it right on top of the original figure. Now this is that wax paper that I was talking about, this patty paper, but you can use any type of paper for tracing. What I want you to do is I want you to hold your pencil on point M, and then we're going to rotate it 90 degrees. Now I could hold my pencil, or just when I rotate 90 degrees counterclockwise. Now, where does this end up? Well, the center of rotation can't move. So just put M right on top of M again. Point M is on top of the original point M. So you can hold your pencil. Like I said, I'll show it again. I can spin this by line it up again. I can hold my point M and spin. But really what I'm doing is I'm just making sure that center of rotation stays fixed. So now see, point M is right on top of point M. Now what I do is I kind of just have to figure out where these points go. So I see P's up here. So I'm just going to flip my paper up, put point P, O's right here. Kind of flip my paper up, put O. I see N is a kind of diagonal away. Put N right there. Q is right here. So I'm going to flip my paper up and put Q in. And then this is my figure. P prime, Q prime, O prime, and N prime. By rotating about point M, this is my new figure right up here. So in that key is to trace it and keep that center of rotation in a fixed position, meaning it doesn't move. My next rotation they asked us to perform is rotating triangle GHI 180 degrees around point F. Point F this time will not move when I spin. So what's going to happen is, like, we're spinning this paper, right? I could just spin the paper as well, but point F is not going to move. So I traced that triangle, right? See, it's already traced. I'm putting it right on top. Notice I did also annotate point F. Point F is going to go right on top of point F. 180 degree spin about point F. Let's spin this. This is a 90 degree spin, 180. So we're going to go completely upside down. But I have to get point F on top of point F. The center of rotation stays fixed. Now all my letters are naturally upside down, but I can still see my shape. Point F is right on top of point F. Now I see where G is. G is right here. So I'm going to just tilt this paper up, mark where G is. H, let me line that up again. H is down here. Get H written down. Always making sure when I move my paper that F stays lined up on top of F. And I is right here. So if I notice that's my new points, it matches up exactly with where my triangle was. So now I'm going to connect all my points. This is G, I prime, H prime. Connect my triangle. And that's my rotated triangle. Okay? Use that tracing paper technique. I think it's the best method to help you. Okay? Now, my next step is doing a reflection of triangle CDE over the line AB. So I'm going to reflect this triangle over AB. In order to do a reflection, count how far away you are from the line. D is 1 unit away from the line. So D prime is going to be 1 unit on the other side. C is 1, 2, 3 units away. So now we're going to count 1, 2, 3 to the other side. Notice E is directly on the line of reflection. That's a very special point. That means that E and E prime are the same exact point. It's not going to move. If my point is on the line of reflection, that's a special case where the point will not move at all. The pre-image and image are the same exact coordinate. Okay? Next up, or last one, is a translation of JKL, and that vector is 3, 2, meaning 3 units to the right and 2 units up. So I'm just going to count 3 units to the right and 2 units up for every single coordinate. 1, 2, 3, 1, 2. So this is where L is. K is 1, 2, 3, 1, 2. K prime. And J, 1, 2, 3, 1, 2. Notice they all move the same exact distance. They all move 3 to the right and 2 up. It's like I just slid that triangle over to the right. That's why translations we sometimes call a slide. I hope this video helps with actually performing your translations. So if you guys need any more explanations, feel free to reach out to me via email or Google Classroom, and I can discuss some more.